The Canadian Standards Association (CSA) develops and maintains electrical installation codes and standards in Canada. The relevant code for generators is CSA C22.1, also known as the Canadian Electrical Code, or CEC. The CEC mandates that generators undergo testing at 100% of their rated load for a minimum duration of 30 minutes. This is explicitly stated in CSA Section 86, which addresses generators. Specifically, CSA Rule 86.308 states that a generator shall be tested for a duration of not less than 30 minutes at rated load. This 100% load testing requirement has been a long-standing practice. However, generators installed in the past may have been subject to different code requirements that were in effect at the time. To ascertain the specific requirements applicable to the generator when it was initially installed, several steps can be taken. Firstly, consult local building codes. Contact the local building department to obtain copies of the electrical codes that were enforced during the installation period. Secondly, examine the manufacturer's documentation. Refer to the original installation manual and any other documentation provided by the generator manufacturer, as these materials may contain information about the testing standards that were applicable at the time of manufacture and installation. For additional resources and confirmation, the following organizations can be contacted. Firstly, the CSA Group, which can be found online, develops and maintains the CSA C22.1 standard. Secondly, the Electrical Safety Authority, ESA, which also has an online presence, is responsible for electrical safety in Ontario. Thirdly, the Technical Standards and Safety Authority, TSSA, also with an online presence, oversees safety regulations in Ontario, including those related to generators. It is highly recommended to engage a qualified electrician to conduct a thorough test of the generator. This will ensure compliance with current code requirements, providing assurance that the generator will operate effectively during a power outage. A generator must provide the required power under a load. The testing of generators typically involves a series of procedures designed to verify their performance, reliability, and safety. These tests can be performed during initial commissioning, routine maintenance, or after repairs. Here are some common generator tests. Firstly, visual inspection. A thorough visual inspection is conducted to check for any physical damage, loose connections, leaks, or other apparent issues. The inspection includes examining wiring, fuel lines, exhaust systems, and control panels. Secondly, starting test. This test verifies the generator's ability to start automatically and manually. It includes checking the starting system, batteries, and control circuits. The time it takes for the generator to start and reach its rated speed is also recorded. Thirdly, load testing. Load testing is a critical part of generator testing. It involves gradually increasing the load on the generator to its rated capacity to observe its performance under different load conditions. Load testing helps identify any potential issues such as overheating, voltage drops, or frequency instability. The load is typically applied using resistive load banks, which simulate real-world electrical loads. Fourthly, voltage and frequency regulation. During load testing, voltage and frequency are continuously monitored to ensure they remain within the specified limits. The voltage regulation test checks the generator's ability to maintain a stable voltage output as the load changes. The frequency regulation test verifies that the generator maintains a constant frequency, typically 60 Hz in North America, regardless of the load. Fifthly, transient response test. This test assesses the generator's ability to handle sudden changes in load. It involves applying and removing large loads quickly to observe the voltage and frequency response. A generator with good transient response will quickly stabilize the voltage and frequency after a sudden load change. Sixthly, harmonic analysis. Harmonic analysis measures the level of harmonic distortion in the generator's output voltage. High harmonic distortion can cause problems with sensitive electronic equipment. Harmonic filters may be required if the harmonic distortion exceeds acceptable limits. Seventhly, insulation resistance test. This test measures the resistance of the insulation in the generator's windings. Lower insulation resistance can indicate insulation damage, which can lead to electrical faults. A megameter, also known as a mega, is used to perform this test. 8th, ground resistance test. This test measures the resistance between the generator's frame and ground. A low ground resistance is essential for safety, as it ensures that fault currents will flow to ground, tripping protective devices. 9th, synchronizing test. For generators that operate in parallel with the utility grid or other generators, a synchronizing test is performed to ensure that the generator can be connected to the grid or other generators without causing damage. This test verifies that the voltage, frequency, and phase angle of the generator match those of the grid or other generators. 10th, protection system testing. The generator's protection system, which includes circuit breakers, relays, and other protective devices, is tested to ensure that it will operate correctly in the event of a fault. This includes testing overcurrent protection, overvoltage protection, undervoltage protection, and ground fault protection. 11th, fuel consumption test. This test measures the generator's fuel consumption at different load levels. This information is used to estimate the generator's operating costs and to determine the size of the fuel tank required for a given runtime. 12th, exhaust emissions testing. For generators that are subject to emissions regulations, exhaust emissions testing is performed to ensure that the generator meets the required emissions standards. This includes measuring the levels of pollutants such as nitrogen oxides, carbon monoxide, and particulate matter. 13th, temperature monitoring. During load testing, the temperature of various generator components such as the windings, bearings, and exhaust system is monitored to ensure that they do not exceed the rated limit. Overheating can damage the generator and reduce its lifespan. 14th, vibration analysis. Vibration analysis is used to detect abnormal vibrations in the generator. Excessive vibration can indicate mechanical problems such as unbalanced rotors, loose bearings, or misalignment. 15th, oil analysis. Oil analysis is performed to assess the condition of the generator's lubricating oil. The oil is tested for viscosity, acidity, water content, and the presence of contaminants. This information can be used to identify potential problems with the engine and to determine the appropriate oil change interval. The Canadian Electrical Code, or CSA, provides comprehensive guidelines for the installation, operation, and maintenance of generators. Understanding and adhering to these requirements is crucial for ensuring the safe and reliable operation of generators. Here are some key sections and rules within the CSA that pertain to generators. Section 86 of the CSA is dedicated to generators. This section covers various aspects of generator installations, including wiring methods, protection, control, and testing. Rule 86.100 addresses the location of generators. It specifies that generators must be located in well-ventilated areas and protected from physical damage. The location should also allow for easy access for maintenance and repairs. Rule 86.102 covers wiring methods for generators. It requires that all wiring be installed in accordance with the CSA general wiring rules. This includes using appropriate conductors, raceways, and connectors. Rule 86.104 addresses the grounding of generators. It requires that generators be grounded in accordance with Section 10 of the CSA. Proper grounding is essential for safety, as it helps to prevent electrical shock and fire hazards. Rule 86.106 covers the overcurrent protection of generators. It requires that generators be protected by overcurrent devices, such as circuit breakers or fuses, to prevent damage from overload or short circuits. The overcurrent devices must be sized appropriately for the generator's rated current. Rule 86.108 addresses the control of generators. It requires that generators be equipped with a means of disconnecting them from the electrical system. This can be a circuit breaker, a switch, or other suitable disconnecting device. Rule 86.300 covers the testing of generators. It requires that generators be tested to ensure that they meet the requirements of the CSA. The testing must be performed by qualified personnel and documented in writing. Rule 86.302 specifies the requirements for generator nameplates. It requires that generators be marked with information such as the manufacturer's name, model number, rated voltage, rated current, and rated frequency. Rule 86.304 addresses the installation of generators in hazardous locations. It requires that generators installed in hazardous locations comply with the requirements of Section 18 of the CEC. Hazardous locations are areas where there is a risk of fire or explosion due to the presence of flammable gases, vapors, or dust. Rule 86.306 covers the installation of generators in healthcare facilities. It requires that generators installed in healthcare facilities comply with the requirements of Section 24 of the CSA. Healthcare facilities have special requirements for emergency power systems to ensure the continuity of critical services. Rule 86.308 specifically mandates load testing. A generator shall be tested for a duration of not less than 30 minutes at rated load. It is important to consult the latest edition of the Canadian Electrical Code and any applicable local amendments to ensure compliance with all relevant requirements. The CEC is updated regularly to reflect changes in technology and best practices. The Canadian Standards Association (CSA) offers a range of resources to help individuals and organizations comply with the Canadian Electrical Code and other electrical safety standards. These resources include publications, training programs, and certification services. The CSA C22.1 handbook is a comprehensive guide to the Canadian Electrical Code. It provides detailed explanations of the code requirements and practical guidance on how to comply with them. The CSA also offers a variety of training programs on electrical safety, including courses on the Canadian Electrical Code, electrical safety in the workplace, and arc flash hazard awareness. These training programs are designed to help individuals and organizations improve their electrical safety knowledge and skills. The CSA provides certification services for electrical products and equipment. CSA certification indicates that a product has been tested and meets the applicable safety standards. The Electrical Safety Authority (ESA) is responsible for promoting electrical safety in Ontario. The ESA offers a variety of resources to help individuals and organizations comply with electrical safety regulations, including publications, training programs, and inspection services. The ESA publishes a variety of guides and bulletins on electrical safety topics, such as grounding, wiring methods, and overcurrent protection. The ESA also offers training programs on electrical safety for electricians, contractors, and other professionals. The ESA conducts inspections of electrical installations to ensure compliance with the Ontario Electrical Safety Code. These inspections help to identify and correct electrical hazards, reducing the risk of electrical shock and fire. Technical Standards and Safety Authority (TSSA) is responsible for regulating a variety of industries in Ontario, including electrical safety. The TSSA offers a variety of resources to help individuals and organizations comply with electrical safety regulations, including publications, training programs, and inspection services. The TSSA publishes a variety of guides and bulletins on electrical safety topics, such as generator safety, electrical equipment safety, and electrical contractor licensing. The TSSA also offers training programs on electrical safety for electricians, contractors, and other professionals. The TSSA conducts inspections of electrical installations to ensure compliance with the Ontario Electrical Safety Code. These inspections help to identify and correct electrical hazards, reducing the risk of electrical shock and fire. When evaluating generator performance and testing results, several key parameters should be considered to ensure the generator is operating within acceptable limits and meeting the required standards. These parameters provide insights into the generator's stability, efficiency, and overall health. Firstly, voltage regulation, which refers to the generator's ability to maintain a stable output voltage under varying load conditions. Ideally, the voltage should remain within a specified percentage of the nominal voltage, typically plus or minus 1% to 2%. Excessive voltage fluctuations can damage connected equipment. Secondly, frequency regulation, which is the generator's ability to maintain a stable output frequency, usually 60 Hz in North America. Similar to voltage, the frequency should remain within a narrow range, typically plus or minus 0.5%. Frequency deviations can affect the performance of electrical devices and systems. Thirdly, load capacity, which is the maximum load that the generator can handle without exceeding its rated voltage, current, and temperature limits. Load capacity is typically expressed in kilowatts or kilovolt amperes. Exceeding the load capacity can lead to overheating, voltage drops, and potential damage to the generator. Fourthly, transient response, which is the generator's ability to quickly respond to sudden changes in load. A good transient response means that the voltage and frequency will quickly stabilize after a load change, minimizing the impact on connected equipment. Fifthly, harmonic distortion, which refers to the presence of harmonic frequencies in the generator's output voltage. High harmonic distortion can cause problems with sensitive electronic equipment, such as computers and programmable logic controllers. Total harmonic distortion, or THD, is a common measure of harmonic distortion. Sixthly, fuel consumption, which is the amount of fuel that the generator consumes per unit of time, typically expressed in gallons per hour or liters per hour. Fuel consumption is an important factor in determining the generator's operating costs. Seventhly, exhaust emissions, which are the levels of pollutants emitted by the generator's engine, such as nitrogen oxides, carbon monoxide, and particulate matter. Exhaust emissions must comply with applicable environmental regulations. Eighthly, insulation resistance, which is the resistance of the insulation in the generator's windings. Lower insulation resistance can indicate insulation damage, which can lead to electrical faults. Ninthly, ground resistance, which is the resistance between the generator's frame and ground. A low ground resistance is essential for safety, as it ensures that fault currents will flow to ground, tripping protective devices. Tenthly, temperature, which is the temperature of various generator components such as the windings, bearings, and exhaust system. Overheating can damage the generator and reduce its lifespan. 11thly, vibration, which is the level of vibration in the generator. Excessive vibration can indicate mechanical problems such as unbalanced rotors, loose bearings, or misalignment. 12thly, oil pressure and oil temperature, which are important indicators of the engine's health. Low oil pressure or high oil temperature can indicate problems with the lubrication system. 13thly, coolant temperature, which is the temperature of the engine's coolant. Overheating can damage the engine. 14thly, battery voltage, which is the voltage of the generator's starting battery. A weak battery can prevent the generator from starting. 15thly, runtime, which is the amount of time that the generator can operate on a full tank of fuel. Runtime is an important factor in determining the generator's suitability for emergency power applications. These parameters should be monitored and recorded during generator testing to ensure that the generator is operating within acceptable limits and meeting the required standards. Any deviations from the specified values should be investigated and corrected promptly.